All right, if no questions, then let's start. Last time we were solving this practice sheet and we left at problem number 7. Let's finish that problem and let's move on to new practice sheet. So problem number 7, ice cream usually comes in 1.5 quart boxes and ice cream scoops hold about 2 ounces. However, there is some variability in the amount of the ice cream in a box as well as the amount of ice cream scooped out. We represent the amount of ice cream in the box as X and the amount scooped out as Y. Suppose these random variables have the following means, standard deviations, and variances. So the values are given in the following table. An entire box of ice cream plus 3 scoops from a second box is served at a party. How much ice cream do you expect to have been served at this party? What is the standard deviation of the amount of ice cream served? All right, so we are looking for a first expected value of random variable of an entire box X and plus 3 scoops plus 3Y, which is equal to, since expected value is linear, expected value of X plus 3 expected values of Y. So this is then 48 plus 3 multiplied by 2, 54. Now let's find what is the standard deviation of the amount of ice cream served. So this is a variance of X plus 3Y. Root of that is then root of a variance of X plus 9 variance of Y. Okay. All right, now then plug in these values from the last table and you'll get the answer. Now part B, how much ice cream would you expect to be left in the box after scooping out 1 scoop of ice cream? All right, then we are looking for expected value of X minus Y. So this is expected value of X minus expected value of Y. So 48 minus 2, 46. What is the standard deviation of the amount left in the box? So we're looking for root of variance of X minus Y, which is equal to root of variance X plus variance of Y. Okay. And then plug in the numbers and you'll get the answer. All right, guys, any questions? If no question, yep.
Can you explain why we changed the sign?
Here you mean?
Mm-hmm.
Yeah, well, general formula for variance of linear combinations for linear combination of random variables is following. So let's say we have linear combination of 2 random variables. Then this is a squared variance of X plus b squared variance of Y. Okay. So by this reason here we have linear combination 1 multiplied by X plus minus 1 multiplied by Y. So the idea is following, even if you are subtracting one variable minus second one, variabilities will add up. Okay. All right. Any other questions? This formula can be extended, for instance, in the following manner. Let's say you have sum of AIs, XIs, then you will end up with the following sum. Okay. All right. Any other questions? If no questions, let's keep moving. Now, our next worksheet. Today we'll start looking at normal distribution. So problem number 1, because serum cholesterol is related to age and sex, some investigators prefer to express it in terms of z-scores. If X is equal to raw serum cholesterol, then Z is equal to X minus mu over sigma, where mu is the mean and sigma is the standard deviation of serum cholesterol for a given age sex group. Suppose Z is regarded as standard normal variable, then what is probability of Z being less than 0.5? All right, guys. Have you had chance to look over the videos for normal distribution? Let's assume that if X follows normal distribution, for normal distribution, we have two parameters. The first one is mean, and second one is variance. Let's assume that we have random variable X following normal distribution. Then if we apply the following transformation, X minus mu divided by sigma, then this random variable will follow standard normal distribution with mean 0 and variance of 1. Okay. And in this case, Z here is standard normal, and they apply this transformation to be able to compare values of serum cholesterol between two groups. So for instance, let's say males and females, they will have different means and standard deviations for raw serum cholesterol. And for instance, if you, let's say, I'm not sure what are the units in which raw serum cholesterol measured, but let's assume that if you take an individual from a female group and you find value for X raw serum cholesterol equal to 150 and some units, let's say grams, and you select second individual from males group, and let's assume that this value is equal to 1. The raw serum cholesterol for that individual is equal to 180. You cannot compare those two values right away, since, for instance, let's assume that males have higher level of raw serum cholesterol on average. So you have to find the ways to standardize those values to be able to compare them. Basically make them unitless. And we do the following transformation. Now this Z variable has no units. And yeah, also Z is then standard normal, follows standard normal distribution, and let's find probability that Z is less than 0.5. All right, first, Let's show that using spreadsheets. So function for spreadsheets for normal distribution is norm_dist. So there are a couple of functions, norm_dist and norm.dist. There is no difference between these two. Now we need to find the probability that z is less than 0.5. For x, we put 0.5. Mean, we put 0. For standard deviation, we put 1. And for cumulative, we put true. So if you remember, putting cumulative true will turn, if we put true for cumulative, we are working with CDF, and false, we are working with PDF. Okay, so we need CDF here. So the answer is 0.69. Right, second way to calculate standard normal values is through the use of standard normal table. Normal table. All right, here is the standard normal table. Then we are looking for probability that z is less than 0.5. So 0.5 will be somewhere here. And we are looking for probability that z is less than 0.5. So we are looking for an area in the left tail. And the values are provided here. So 0.5 is 0.69. That's the ones that we calculated before. Okay. And if you recall, standard normal distribution has mean of 0 and variance of 1. So it is also symmetric about 0. All right, and finally, let's show how to find this value using R. So if you recall from previous class on Monday, for instance, if we want to find if we want to work with distribution function of any random variables, then we have to start with the letter P. Then if you need binomial, you start writing down binomial and it will suggest you some variables. Not in our case now, we need normal distribution. We start writing down norm and it suggests us to use norm. Now for Q, we put 0.5. For mean, we put 0. For standard deviation, we put 1. So we are working with standard normal. Then you can leave other parameters set to default values. For lower tail, we will put true. So if we put for lower tail true, then it will give us values that lie to the left of our given point here. If we put for lower tail false, then we are working with the right tail and it will calculate probability that our random variable is greater than this value here. Okay. So we'll put, so we'll leave it for default values, and the answer is 0.69 as the ones that we have seen before. Okay. All right, guys, any questions so far? Okay, if no questions, let's keep working. Now let's find probability that z is greater than 0.5. Okay, so now let's use this parameter for lower tail, so 0.5, mean 0, standard deviation of 1, and for lower tail we'll put true. We'll put false. So we will calculate probabilities that lie to the right of our point. So 0.31. Now, if we were to use Excel, we would calculate it in the following way: one minus our probability that we calculated before. Okay, there is no option to set parameter for table values. Always leave cumulative true when we are working with continuous distributions. And then since here we calculated, so let's assume that 0.5 is somewhere here. We calculate probability that z is lies to the left of this value, z is less or equal than 0.5. Then to find this probability in the right tail, we need to subtract the probabilities that we haven't found before. Okay. All right. Now, what is probability that z lies in range from -1 to 1.5? All right, so let's calculate that. This is norm gist from -1 to 1.5, right, guys? If I recall correctly. Yes. So 1.5, mean 0, standard deviation 1, cumulative true, minus norm gist. For x, we put -1. For mean 0, standard deviation 1, and true for cumulative. All right, so here's the probability. Okay. By the way, guys, CDF of standard normal has special notation. So CDF for standard normal, let's assume that if Z is standard normal, with mean of 1 and variance, with mean 0 and variance of 1, then probability that Z is less or equal than some value, let's say A, is given as CDF of our random variable Z, and it has special notation as big phi. Okay. So CDF of standard normal is given as big phi. All right, now next problem. Suppose a person is regarded as having high cholesterol if Z is greater than 2 and borderline cholesterol if Z is an interval from 1.5 to 2. What proportion of people have high cholesterol? Okay, well, again, let's find that. So Z is greater than 2. Let's, for instance, use R this time. P norm, Z should be greater than 2, mean of 0, standard deviation of 1, and which value should I select for lower tail if we need to calculate Z greater than 0, than 2? Guys, don't be shy. Which value do I need to select for lower tail parameter? Yep, absolutely right. So I need to put false here. So this probability is 0.022. So 2.2%. If we were to calculate that using spreadsheets, then we need 1 minus norm gist, 2 mean 0, standard deviation of 1, cumulative true. Okay, so 2.2%. as the previous value that we have calculated. All right, now what proportion of people have borderline cholesterol in interval from 1.5 to 2? So this is norm gist 2011 minus norm gist 1.5 0111. Okay, so 4.4% have borderline cholesterol. Okay, now suppose next problem. All right, guys, any questions regarding first problem? Okay, if no questions, let's keep moving. Now, next problem. Suppose that total carbohydrate intake in 12 to 14-year-old boys is normally distributed with mean of 124 grams per 1,000 calories and standard deviation of 20 grams per 1,000 calories. All right, then let's assume that carbohydrate intake is denoted as random variable x. Then x follows normal distribution with parameters. So notation is following for to show that x follows normal distribution. First parameter is mu, mean of 124, and second parameter is variance. More commonly, we use, we rarely use variance when working with distributions. We usually use standard deviation, but the standard notation to show that x follows normal distribution, second parameter here should be not standard deviation, but variance, okay? So variance should be equal to 20 squared, okay? All right. What percentage of boys in this age range have carbohydrate intake above 140 grams per 1,000 calories? So we need to find probability that x is greater or equal than 140. Okay, now let's calculate that. Let's, for instance, use R. So for CDF, we need P norm, 140. Mean was, let's come back. Mean was 124. Mean was 124. And standard deviation was 20. If you guys forgot which parameters to put, you can, in our studio specifically, you can press tabs and it will suggest you the parameters that you can fill in. So for lower tail, what do I need to put for lower tail, guys? If I need to calculate probabilities that x is greater or equal than 140. I need to put false, right? I need right tail, so we'll put false here. So probability then is around 21%. Okay, and let's show the same using spreadsheets. For spreadsheets, if I need right tail, then I need to start with 1 minus norm list. 140, 124, standard deviation is 20, but that's true always for cumulative, so 21%. Now, if we were to use standard normal table, then first we need to standardize our value. So right now we have we need to find probability that x is less or equal than, I mean, greater or equal than 140. Any ideas how can I use this table here, guys, to find this value? So if you recall, X follows normal distribution, mean of 124 and standard deviation of 20. So I can move from any general normal distribution to standard normal distribution by applying the following transformation: X minus mu divided by sigma. So this, if I subtracted minus mu and divide by sigma from the left side, I need to do the same operation from the right hand side of my inequality. So 140 minus 124 divided by 20. Okay. All right, then this here is standard normal. Probability Z is greater or equal than, this is 16 over 20, or probability Z is greater or equal than 0.8. Then to use this table here, given here, I need, I find this probability here in the following way. So let me write it here. 1 minus probability Z is less or equal than 0.8. Okay. 1 minus probability Z is less than 0.8. So let's find this value, 0.8 here, and this is 78%. 1 minus that, you can see, guys, that we get the same value as we calculated using spreadsheets in R. Okay. All right, guys, any questions so far? So from any general normal distribution with mean mu and standard deviation of sigma, we can move to standard normal, applying the following transformation: X minus mu divided by sigma. All right, so what percentage of boys in this age range have carbohydrate intake below 90 grams? Okay, let's calculate that using R, using spreadsheets. So below 90, so 90, 124, 20, and true for cumulative, so 4.4%. Next, suppose boys in this age range who live below the poverty level have a mean carbohydrate intake of 120 grams with standard deviation of 19. Okay, so Y follows normal distribution with mean 121 and standard deviation of 19. Okay, answer problem 5.6 in this age range. Okay, let's use R this time. So 121 and 19. First, I need to find probability that Y is greater than 140. So 140, mean is 121, standard deviation is 19 now. For a lower tail, I will need false. So this is 15.8%. Okay. Now we can see that probability is smaller since now our mean is less, guys. Okay. And I will, let's keep this problem, guys. We'll work it out as a homework. Okay. All right, now next problem. Now, I believe this problem, guys, is similar to the previous problem. Uh, try to solve it at home. Try practice working with spreadsheets or R or tables. I would not recommend using tables since you'll be slower than if you were to use Excel or spreadsheets or R. Okay, you will be allowed to use spreadsheets on and R on exams and quizzes, right? Okay, now let's move on to the problem number 4. What z-score corresponds to 75th percentile of normal distribution? Okay, let's answer that question using, let's say, spreadsheets. So I need to find a point such z that corresponds to 75th percentile. So I need 75% lying in the left tail here. And I need to find that z-score that corresponds to this point here, to such point here, okay? In Excel, we have function norm inverse. So basically, this is an inverse function of CDF of normal distribution. So for X, we'll put 0.75. For mean, we'll put 0. And for standard deviation, we'll put 1. So since we are working with standard normal, then this value is 0.67. So this point corresponds to 0.67. Okay. To the left of point 0.67 will lie 75% of my points. Okay. Right. Next problem. All right. So 25th percentile. All right, guys. Who can answer this question right away? Which point z-score corresponds to 25th percentile? Using the information that we have derived just now. So we found that 75th percentile corresponds to 0.67. We can quickly figure out which point corresponds to 25th percentile. So if you recall, standard normal distribution is symmetric about its mean, and its mean is located at 0, so it is symmetric about 0. What does that mean? It means that, so for instance, this point here corresponds to 75th percentile. The point that we found just now, which was 0.67, 0.67. So it means that we have 25% of area lying in the right tail. So what is the value of this point of 25th percentile then, guys? So I need 25% area now lying in the left tail. So it is if it is symmetric about 0, guys, then it is negative value. This is z, then minus 0.67. Okay. All right, guys. Let's keep moving. So the median, right? Which z-score corresponds to median, guys? Can answer that right away.
0.
Yep, absolutely right. In case when we are working with symmetric distribution, guys, mean is equal to mean. And this is exactly our case for normal distribution. Mean is equal to median, and mean corresponds to 0 z-score. Okay, lifetimes of batteries in certain application are normally distributed with mean 50 hours and standard deviation 5 hours. Find the 40th percentile of battery lifetimes. So mean is 50 and standard deviation 5. We need to find 40th percentile. Now let's show that using RStudio. In RStudio, when you are working with inverse of your CDF, you always start with Q, which is also known as quantile function, which is going to give us values of points that correspond to certain quantiles. So Q norm, we need 40th percentile, so 0.4, mean was equal to 50, and standard deviation was equal to 5. So for SD, 5. Yep. So for other parameters, you can leave them as it is, since we need left tail, so lower tail being true is fine. So 48.73. Okay. So basically, if you draw normal distribution here, its mean is at 50 and standard deviation is 5. Then we found that 48.7 here corresponds to 40th percentile. So area under the left tail here is equal to 40%. Okay. All right. Now, next problem. We have time for our last problem. Okay, guys, any questions so far? Okay, if no questions, next problem. In the article, advances in oxygen equivalent equations for predicting the properties of titanium welds, the authors propose an oxygen equivalence equation to predict the strength, ductility, and hardness of welds made from nearly pure titanium. The equation is E is equal to 2C plus 3.5N plus O, where E is oxygen equivalence and C, N, and O are proportions by weights in parts per million. Assume that for particular grade of commercially pure titanium, the quantities C, N, and O are approximately independent and normally distributed. Okay, so C, N, and O, they follow normal distribution. Mean of mu C is 150. Standard deviation is 30. This follows with mean, let's leave it as mu n, sigma n squared, mu O, sigma O squared. We'll substitute values later on. Let's find the distribution of E. So we need to find distribution of E, which is equal to 2C plus 3.5N, 3.5N plus O. All right, guys, so let's start by taking a look at first at the sum of two random variables that follow normal distribution. So for instance, if we have X and Y, and let's assume that both are normally distributed, then their sum is also going to follow normal distribution with mean, which is simply equal to the sum of the means of those two distributions, and a variance, which is equal to the sum of variances. So sigma x squared plus sigma y squared. Okay. In case, let's assume if you will have x minus y, then mean is going to be, mean of their difference is going to be mu x minus mu y. However, the variance is still is going to be the sum of this will be equal to the sum of the two variances, which brings us to the general formula. Let's write it in the following way. Let's assume if you have x1 that follows normal distribution with mu1 and let's say sigma 1 squared, and x2 which follows normal distribution and so on, and let's say xn here. Those are not IIDs. These are not independent identical distributed. They each follow its own normal distribution with mean of mu I and variance of sigma I squared. Okay, so this is mu n and sigma n squared. Now, if you are looking for, let's say, a random variable a1 x1 plus a2 x2 and so on, so where ai's are constants an xn, then this random variable here is going to follow normal distribution with mean of, so you have to simply take mean of this linear combination, which is going to give you a1 mu of x1 mu1 plus a2 mu of x2, which is mu2, and so on. Okay, an mu of n. All right, now and if you take a variance of this linear combination, then you need to square your coefficients, a1 squared sigma 1 squared plus a2 squared sigma 2 squared and so on. Okay, so what we see here is an squared sigma n squared. If we have random variables that are normally distributed, then their linear combination is also going to be normally distributed. Okay, so this is exactly our case here. This is linear combination of our normally distributed random variables. Then E is going to follow normal distribution with mean that is equal to 2 mu c plus 3.5 mu n plus mu o. And standard deviation is going to be equal to 4 sigma, variance, 4 sigma c squared plus 3.5 squared mu n squared plus mu of o squared. Okay, then substitute the values that are given here and you find the distribution of E. Okay, we also need to find probability that E is equal to E is greater than 3000. Okay, guys, when you substitute these values, you'll find mean of your new normal distribution and standard deviation and variance, and then calculate that using Excel or R. All right, guys, any questions? Any questions regarding the midterm?
Hello, Professor. Should we enter Zoom during the midterm or just record using OBS?
No, just record using the OBS.
Thank you.
Okay. All right, guys, if no questions, that's it for today. See you on Monday. Have a great day. Goodbye.
Thank you.
Bye.
Thank you. Goodbye.